Welcome to our video. I am Sophia from EagleCooleer. At EagleCooleer, we mainly offer three types of signal wires: PWM, TACO, and RD. In next few minutes, I will explain what they are and their work principles. Now, let's come to PWM signal first. Pulse width modulation, PWM, is a technique used to control the fan speed by varying the pulse width. It is a single input from out-east control board to control fan speed. Here, we come to PWM work principle. The fan adjusts its speed by measuring how long the signal is on compared to the total cycle time, known as the duty cycle. By changing how long that the fan motor is powered on during each cycle to adjust the fan output power and then fan speed. Next, let's study some related concepts of PWM signal. Cycle time is the time which takes for a signal to go from the high level, on time, to the low level, off time, and back to high level, on time, shown as red color waveform, T, in the figure. Now, we are going to the most important concept, duty cycle, which is the ratio for the time PWM signal remains high level, on time, against one cycle time, saying the percentage of the time PWM signal remains at high level, on time. For examples, regarding first cycle in green color, PWM signal remains on high level, on time, for 7 milliseconds and low level, off time, for 3 milliseconds, so duty cycle is 70%. In the same way, we can get the duty cycle for red waveform, 40%. Here we introduce another concept, pulse width, which is the time PWM signal remains on high level, on time, in one cycle. From the chart and video, you can see different output waveforms from different duty cycles. Here shows how our PWM signal works. Please note that normally the control signal frequency for the fan should be between 18 kHz and 25 kHz. 2. The preferred operating point for the fan is 25 kHz. 3. At 100% duty cycle, the rotor will rotate at its maximum speed. 4. When the control signal wire is disconnected, the fan will rotate at maximum speed. For sure, we can customize PWM signal as required by your side. How? Let's come to TACO signal. TACO signal, also called FG signal, is the output signal from the fan used to detect the fan's rotational speed. Its signal resources come from the internal Hall sensor signal of the fan. From the picture you can see, there are two types of Hall sensor for speed detection, Hall IC and external Hall sensor. Please note that since the complexity of Hall IC's programming will cause electromagnetic interference, which can reduce the precision of speed measurements, it is better to use external Hall sensor for high power consumption DC fan. When the fan operates, the alternation of magnetic poles, i.e., north and south poles, on its rotor causes fluctuations in the electrical signal's high and low levels. The faster the rotor spins, the quicker these fluctuations occur. These changes result in the generation of a square wave signal, whose frequency can be measured to determine the fan's rotational speed. Here, we can come to know how to work out fan speed. Fan speed / minute is equal to FG frequency * 60 seconds / number of pole pairs. Since frequency is equal to 1 / cycle. Therefore, fan speed can also be calculated as 1 by 60 seconds / 2 * cycle, finally to be 30 / cycle. Here shows how our TACO signal works. Next, let's come to RD signal. Rotation detection, RD, signal is the output signal from the fan used to detect whether the fan is operating. Its signal source comes from Hall signal. Now, we are talking about RD signal working principle. Normally, when the fan operates, the signal outputs at low level and when stopped, at high level. Some customer uses the opposite state, which is called as RRS. Please note that RD signal belongs to the simple circuit alarms and does not require MCU processing. Here shows how our RD signal works. Through the previous explanation, I hope you can get a clear picture how the signal wires work. If any other questions, please email or call us.